Mechanical mouse. The mechanical mouse is one of the earliest types of computer mice used with personal computers. It works using a rubber or metal ball underneath the device that rolls as you move it across a surface. Inside, small rollers detect the ball's movement and translate it into cursor movement on the screen. These mice became common in the 1980s and 1990s alongside early desktop systems. What made them distinctive was their physical tracking system, which required regular cleaning because dust would collect on the rollers. They matter because they introduce millions of people to graphical user interfaces and helped define how we interact with computers today. Optical mouse. The optical mouse replaced the rolling ball with a light-based tracking system. Instead of mechanical parts, it uses an LED light and a tiny sensor to take rapid images of the surface beneath it, calculating movement from those images. Optical technology became popular in the late 1990s as it proved more reliable and easier to maintain than mechanical designs. Without moving internal parts, it reduced wear and eliminated the need for cleaning rollers. It matters because it made computer input smoother, more accurate, and more durable for everyday users. Laser mouse. The laser mouse builds on optical technology but uses a laser diode instead of a standard LED. This allows it to track movement with greater sensitivity and on a wider variety of surfaces. It began appearing in the early 2000s as higher precision became important for gaming and professional design work. What sets it apart is its higher DPI or dots per inch, which measures how finely it can detect movement. The laser mouse matters because it pushed mouse accuracy to new levels, supporting tasks that demand detailed control. Wired mouse. The wired mouse connects directly to a computer using a cable, traditionally through PS2 ports and later through USB. It draws power from the computer itself, which means it does not need batteries. Wired mice have been standard since the early days of personal computing and remain widely used today. Their main difference is reliability, as they offer a stable connection with no risk of wireless interference or battery drain. They matter because they provide consistent performance, especially in professional and gaming environments where stability is essential. Wireless mouse. The wireless mouse removes the physical cable and connects using radio frequency or Bluetooth technology. It communicates with the computer either through a small USB receiver or built-in wireless hardware. Wireless models became mainstream in the early 2000s as laptops grew more popular and desk setups became more minimal. The key difference is freedom of movement and reduced cable clutter. This type matters because it supports portability and cleaner workspaces, fitting modern habits of working across multiple devices. Trackball mouse. The trackball mouse reverses the idea of moving the entire device. Instead, the body stays still while the user rotates a large ball with their fingers or thumb. Trackballs have existed since early computing experiments and gained popularity among users with limited desk space. What makes them different is that cursor movement comes from spinning the exposed ball rather than sliding the device. They matter because they reduce arm movement and can be more ergonomic for certain users, especially in compact or specialized work environments. Gaming mouse. The gaming mouse is designed specifically for video games that require fast reactions and precise control. It often includes high DPI sensors, customizable buttons, adjustable weights, and advanced software. As competitive gaming grew in the 2000s, companies began creating mice tailored for different play styles. What sets it apart is not just sensitivity, but programmability and ergonomic shaping for long sessions. Gaming mice matter because they reflect how input devices have evolved to meet the demands of performance-driven digital experiences. Ergonomic mouse. The ergonomic mouse is shaped to reduce strain on the hand and wrist. Unlike traditional flat designs, it may have a vertical grip or sculpted curves that support a more natural hand position. These designs emerged as awareness of repetitive strain injuries increased in office environments. What makes it different is its focus on comfort and long-term health rather than just speed or precision. It matters because it addresses the physical impact of extended computer use, helping users work more comfortably over time. Touch mouse. The touch mouse replaces physical buttons and scroll wheels with a touch-sensitive surface. Instead of clicking mechanical switches, users tap or swipe on a smooth panel to perform actions. This design became more common as touch technology improved and blended with traditional desktop input. What sets it apart is its gesture support, allowing actions like scrolling or switching windows with finger movements. It matters because it bridges the gap between mouse-based control and touchscreen-style interaction, reflecting the broader shift toward gesture-based computing. Vertical mouse. The vertical mouse rotates the traditional design so the hand rests in a handshake position. This reduces the twisting of the forearm that happens with flat mice. It gained attention in the 2000s as ergonomic research highlighted wrist strain from prolonged computer use. Its defining feature is the upright orientation, which changes how the user grips and clicks. The vertical mouse matters because it represents a thoughtful redesign of a familiar tool, aiming to make everyday computing healthier without changing how the cursor behaves on screen.